At the end of the previous video, we were wondering where that RIP route went, and I did want to verify for you that the RIP update for that network is still coming in from router 2 over the broadcast segment. And so what I did really quick during our short break is took a sip of coffee, and then I ran debug IP RIP, clear IP route asterisk to force an update, and you can see very quickly we got a version 2 update from router 2 over the broadcast segment. There's the network. So it's not like it's not getting the RIP route because we wrote the static route. That one didn't cause the other. So what exactly is going on here right now? Well, right now the router is learning about that network from two different sources. It's learning about it via RIP, and it's learning about it via the static route we wrote at the end of the previous video. Now, since the mask is the same length for both of the updates, we got to have a tiebreaker. And what's a tiebreaker we talked about earlier? Administrative distance. Static routes have an AD of 1, where RIP routes have an AD of 120, so the static route is going to be installed into the IP routing table. The only way the RIP route is going back into the IP routing table is if that static route disappears. And we're going to make it disappear in a minute because what we have right now doesn't meet the requirements of the lab, because all the traffic from router 1 to network 2 is going over the serial link, which isn't going to make our client happy. It's not going to make us happy either. So we're going to fix that in a moment. Very first thing I'm going to do here, though, is take that static route off. I'm going to use my up arrow to go through my history, and then use Control A to go to the front of the line and type no. I know I've mentioned this in a couple of other videos, but I'll mention it again. I don't use a lot of keyboard shortcuts, but I've always found those to be helpful. Just up and down arrow to go through your history, and then Control A moves the cursor all the way to the front. And if you're negating a command, that's a quick way to do it. Just put the word no in front of it. So right now, if I run show IP route RIP, you'll notice the RIP route is back in the table because that static route is gone. And what we need then is some other kind of static route. And what we need to do is to raise the administrative distance of the static route. If we raise that to a value greater than 120, the RIP route would be installed in the routing table, and it would stay there because we see it's back now after taking the regular static route off. And the floating static route would be used only if the RIP route disappeared. Pretty cool, huh? And when we raise the AD of a static route, that's what makes it a floating static route. It's kind of floating out there in limbo. That's kind of my explanation. That's not the official textbook explanation. But to me, that's what it does. It floats out there in limbo. And it's just floating there until it's needed. And right now, with that RIP route of an AD of 120, if we give the static route an AD of 121, then it should just float out there and only enter the table if it's needed. So on the board here, I talked about removing the current static route, checking the IP routing tables, RIP routes. We already did that. So let's go ahead and take a look at a floating static route. And I'm going to go with the whole command here. IP route, and we'll go with 2220 there, or not. And we're going to go with the same mask. And we're going to go with the same next hop IP address. And you're thinking, boy, that looks amazingly like the regular static route you wrote. And it is. Let's check the values at the very end here, though. Now, we don't see the word floating here anywhere, so it must be something else. What is it? It's that distance metric for this route. What you're doing when you set that, it doesn't say administrative distance, but that's actually what it means, distance metric for this route. So there is no rule that says you just need to set this one higher than the routing protocol in action, but it's good best practice. So what I'm going to do is set the AD of this floating static route to 121. And I still have other options, but I don't need any, and that's it. So does that little 121 on the end of this command really make that big a difference? Let's find out. Let's go ahead and run show IP route RIP. And we see that that's still in the table. And I'm going to go ahead and force an update because we know how RIP is. And there's a brand new update, and it's still going straight into the routing table. So the floating static route that we wrote, it's floating out there right now. It's not in use. And let's run show IP route static. nothing there because that route's not in the routing table. Let's run show IP route 2220. And you can see I put an extra 0, I put an extra 2 in there, but it showed routing entry for 2220/24 because that matched the address I put in. And we see it's known via RIP, distance 120, and everything is as we want it. Let's go ahead and do a trace route anyway. We're just going to verify the heck out of this one. Plus, I like you to see the commands more often. And you can see the next hop IP address for packets going from router 1 to router 2's loopback. The next hop is 12.1.1.2. So everything is beautiful, but we got to test this thing. How are we going to test it? We did something like that in the last video. We're going to take 2000 out of router 2's RIP config. And I'll hop over to 1, and we'll do a show IP route RIP, see if it's left the table yet, and it already has. How about that? So, if things are working correctly now, when I run show IP route static, we should see the static route, we should see an AD of 121, and then when we do a trace route, it should be using 21.1.1.2 as the next hop. Let's find out what happened. And there it is. The static route is now in the IP routing table because this is the only other source of information that this router has about it. But thanks to the AD of 121, this route wasn't put into the table until the RIP route was gone. So that's exactly what we wanted to see. And let's run a show IP route 220. And known via static, there's that distance again of 121. So that indicates that we do indeed have a floating static route. And we'll do a quick trace route 21.1.1.2. So we have met all of our requirements. Everything is going just as we wanted it to. We're running a routing protocol over the broadcast network. We're not running any routing protocol over the backup link, the serial link. We're using only a floating static route, which enters the table only when the RIP route is gone. So you can see that little 121 has a big effect, and it really comes in handy on occasion. And just to test things, let's make absolutely sure before we leave the client site and go grab lunch on his credit card, just kidding, that we're going to put network 2 back in. And by doing so, once router 1 sees that update, the static route that we wrote, the floating static route, should leave the table, and the RIP route should be back. And there it is. And if we run show IP route static here, we see nothing. And you know what I'm going to do one more time? Let's run a trace route for 2222. Never hurts to check one more time before you leave a client site. And you see the next hop is again 12.1.1.2. So floating static route. There's a fantastic usage for it. I've used them that way in the real world. Works like a charm. And now you know how to do the same. Coming up next, what are we going to do? We're going to introduce a default route in an interesting way in RIP. And I'm going to give you a little bonus information that goes a little beyond the CCNA, but it's good stuff to know. And that is all coming up next.